Hi, my name is Jason. We're going to be going over this problem, integer break. The main question of this problem is you're given an integer. How can you break the integer up such that it sums to the target n? And how can you maximize the product of those integers? So, let's say, for example, you have the integer 6. Whoops. Let's say, for example, you have the integer 6, right? dp of 6. Okay, so here's how you can sum to 6. You have 5 plus 1, you have 4 plus 2, we have 3 plus 3, on and on and on, 1 plus 5. And we can then calculate the product of 6. And the product of 6, the largest integer break would be 9. That is one case of it. And that is the dp of 6, which is 9. The second case is, let's say we have the number 8. How do we calculate the integer break of 8? Well, we have 7 plus 1, 6 plus 2, 5 plus 3, 4 plus 4, on and on and on, 1 plus 7. And when we calculate the product of these, right, we have 7, 12, 15, 16. Now, this is one case. Remember, we can also split up more than just the integer. So what I mean by that is, let's focus on 6 plus 2, right? What's another way of writing this? We can also write this as 3 plus 3 plus 2. This will sum to 8, and if we write it as such, we now have 3 times 3 times 2, which is 18. And thus, the integer break of 8 is 18. Now, there is one question I have, which is, okay, so we know we can split up this 6, right? Well, because this is dynamic programming, we realize, hey, we've actually solved this subproblem before. Where have we seen this 3 times 3, or 3 plus 3 is equal to 6, right? Well, if we look right here, 3 plus 3, we realize we already solved it for dp of 6. And we know that dp of 6 is 9. And what I'm basically saying is we can actually plug in dp of 6, right? And multiply that result by 2, and we get 18. And that is the integer break of 8. So knowing that, how can we actually code this? Let's start with an array, starting from 0. And what we can do is we can actually calculate all of the integer breaks from the bottom up. So I'm going to initiate the array to n plus 1, as we want n plus 1 indexes that we can access. If we do this, you'll realize you have 1, 1, 2, 4, and 5, which is 3 times 2. The integer break of 5 is 6. And finally, we have 6. We can calculate using this, which is 9. And finally, we have 7, which we can say is 4 times 3, or 4 plus 3, which is 12. We have 8, which is, as we calculate below, 18. So what we can do is we can initialize dp of 1 to 1. And when we get to dp of 2, we can calculate, okay, using this method right here. I'm going to call this method A, where we just simply iterate through and we calculate calculate the sums of 6 and the products, and from the products, calculate the integer break. I'm going to call B this case right here, where we actually look at the previous dp solution, where we have dp of 6, well, we have 6 plus 2, or dp of 6 plus 2, and we calculate 18. Now, when we get to actually coding it, let I represent the index of the array that we're currently on as we solve this from I to n plus 1. And finally, let j represent the divisor. Sorry, let j represent the subtractor right here. Now that we have those two things, why don't we go ahead and actually start coding it, right? So we would have, let me just emphasize again, we have I represent this n right here, the target that we're trying to do, and we have j represent this 1, 2, 3, what we're subtracting against. So how can we actually implement this? Well, notice here real quick, this number right here, this 5, is actually calculated by I minus j times j. 6 minus 1 times 1, 6 minus 2 times 2, 6 minus 3 times 3, on and on and on. And finally, we have the exact same case for case B right here, where we have dp of 8 minus 1 times 1, dp of 8 minus 2 times 2, and on and on and on until we get to the point where we reach it. And finally, we can also rewrite this as 7 dp of, So let me just emphasize once again, this is our j, this is our I minus j times I. And now we can actually start coding the solution. Go ahead and start coding our solution. We have dp of 0 is equal to 0 times n plus 1, the length of the array. For I in range 1 to n plus 1, this will be our nth number that we are calculating. Remember, we're calculating this from bottom up. So we're starting from 0, 1, 2, 3, 4, 5, 6, 7, 8. So then we say for j in range 1 to I, why I? Because this j, we're indexing it from 1, 2, 3, all the way up to 5. So that's why we're going from 1 to I. Then let's go ahead and write our cases, right? We have A is equal to I minus j, case A times j. We have case B, which is equal to, well, remember how we said the previous number, so I minus j, which is this case right here, where we have dp of 6, which is also written as 8 minus 2, where 8 is I and 2 is j, like so. We have dp of I minus j times j. And we have the final case, which is if we've already calculated. And we have the final base case, just for if we're calculating the integer break for 1. And what we can do is we can say take the max, dp of I, is equal to the max of these 3 conditions. And finally, once we've solved this bottom-up approach, we can just simply return dp of n. And as a base case, we have dp of 1 is equal to 1. My bad. This should be dp. If we run this code, let's just make sure it works. And let's go ahead and submit. As you can see, this is a solution for this integer break problem.